Hello everyone. In this session we'll discuss regression analysis. So let's see what is it. Regression analysis. This is basically giving information of the, let's say, dependent variable from the independent variable, right? So information of the relationship between a response which is like dependent variable and an independent variable, let's say predictor, so we need to express or we need to create a relationship or a function between these variables. So expressing response as a function of the independent variable and this can be used for prediction with some n number of data is given. If we try to form a relationship between the dependent and the independent variable, then as per this function created or expressed, we can also predict the values it will have for some of the values of the independent variable which is not given in the data, right? So it can be used for prediction, it can be used for model specification, and parameter estimation. And for this, the best method used is least square method. Least square method for estimation, parameter estimation. Of coefficient of regression. So this relationship between the dependent and independent variable can be linear and can be non-linear also. So let's say it can be a straight line which is like f of x equal to a naught plus a1x. It can be exponential model, so this is non-linear. F of x is equal to, let's say, a naught e to the power of a1x, or maybe quadratic or polynomial. F of x is equal to a naught plus, let's say, another constant and third constant x square. And for this, in order to check for the accuracy or check for the goodness or check for the how approximate or how good we are up to the point or how fit it is, we have a measurement which is residual, which is given as EI equal to yi minus f of xi, that is for I equal to 1, 2 and so on up to n. Thing is that 1 we have the exact value as yi, and 1 we can find through the function we have created for this variable y. Now the difference between the value we are getting for f of xi and the exact value for xi given will be the residual, right? So this can be, it is a measure of how the regression model f of x predicts y, right? So basically let's say this is a function we have created f of x, whereas the function value at let's say xi or maybe let's say x1 was y1. This is y1. So the value we are getting through function is this point, whereas the value at this point is y1. So this difference is actually the measure of goodness or measure of accuracy we are going to have, right? So this is the difference between what we are finding through the model created and what it is actually. So this is the difference between this. And what if this is going to be 0? If all the residual EI are 0, what if all the residuals are 0? That can happen only if the model we are trying to create is the exact function for which we are going to have that value, right? So that is how it is to be expressed. Like let's say we have function y is equal to x square, right? So this is an exact function for certain values, like if we have x and y given as let's say -1, 1, 2, -2 and so on, and the values for these x are given like 1, 1, 4, 4, right? Suppose these are the data provided, whereas the function model we are creating is f of x is equal to x square. Then in that case, for all the xi's, the function value we are going to get will be exactly same as the y value for that function, and in that case the error is going to be 0 or the residual is going to be 0. So sum of all these residuals are going to be 0 in this case, right? So if all the residuals EI are 0, 1, there are possibility EI are 0, then possibly we have found the equation or function, anything, in which all the points lie on a model, right? This is the model on which all the points are lying. So if all the residuals EI are 0, then possibly we have found an equation or let's say function in which all the points lie on that model itself. Like for example, if I was drawing this blue line as function of x, f of x, and what if the points are exactly lying on this red dots exactly lying on this function or the model? Then in that case all the residuals are going to be 0, and we have actually found the exact function for that data provided. So let's talk about the linear regression. Of course it can have more number of independent variables, but let's say we have one independent and one dependent variable, and let's say we have this n data points given, like x1 y1 x2 y2 and like that xn yn, and then y equal to a naught plus a1x be the relation by the regression model. If this is the relation we are creating, this a naught and a1 are going to be constants, right? What if we are trying to form this relation, linear relation, which is also known as y on x, where y is the dependent variable and x is the independent variable. So we have this y is equal to a naught plus a1 times of x, and of course the residual ei can be given as yi minus this y we have formed. So this is going to be a naught plus a1x, right? This is the exact value we will have, and this is the function model value we are going to get or predict. So what if all the residuals are going to be 0? Then in that case we have actually found the exact function on which these points are lying, right? So let's see some of these constants and let's see how to calculate this. For all the data provided, this a1 can be given as sum of xi yi for I equal to 1 to n times of this minus sum of product of the sum xi and yi. This is from I equal to 1 to n, I equal to 1 to n, divided by sum of the squares from I equal to 1 to n times minus square of the sum I equal to 1 n square, and this a naught can be given as xi square yi 1 n I equal to 1 and n. So this minus xi product of the sum xi yi I equal to 1 n I equal to 1 n, divided by the same thing, same denominator, xi square I equal to 1 to n minus square of the sum xi square, right? These are the values for a naught and a1, and we can make it in this manner also. Some of the variables like xy, sxy will be given as sum of xi product for I equal to 1 to n minus n times of x bar y bar. These are the mean values, we'll see that, and this xx given by xi square n I equal to 1 minus n x bar square, that is the mean value. So this x bar is given as mean I equal to 1 to n, and y bar is given as similarly summation y I equal to 1 to n by n. So these are the mean values. So overall we can write this a1 to be sxy by sxx, and this a0 can be given as y, that is the mean bar, mean, minus a1 times of x bar. Yes. So these are the expressions we have to remember, right? We have to remember this so that we can use the data or table given, and then we can find all these relations and we can create the relation model. Also we can see the properties for this least square regression. It says the regression line passes through the mean, that is means of x and y. Also the average value of the residual is 0. We have more, but this will be enough.